Let's get started. So here we have a graph of a Ferris wheel. How high above the ground is a person when he gets on the Ferris wheel? 5 feet. See, that would be, normally you don't get on at the top, or there's not like a springboard that you run and jump and fly to the top. That could be fun, but yes. 5 feet above the ground is when you get on. What is the radius of the Ferris wheel? 20 feet. How did you figure that out? So it goes all the way up to 45, and so that means the diameter would be 40 feet. So the amplitude is going to be the radius. Excellent. And how long does it take to make one complete revolution? 2 minutes. So that's not too scary a Ferris wheel. If we change this to seconds, that would be a more scary Ferris wheel. But yes, 2 minutes. So what I'd like to do with this right now is get you to think about each of these things so we could write an equation. If you wanted to write an equation for this, what is our d value? We already said, hey, the radius is the same as our amplitude, so yes, that's going to be 20. What's our d value? And the d value is your sinusoidal axis, right in the middle, 25. Good. So we could just since you figured out your amplitude was 20, you could add 20 to 5 or subtract 20 from 45 to get your d value to be 25. What is our b value going to be? Yes.
Can you just say again how we got 25?
So it's the center line, right? So the question is, how do we find out that that center line is 25? A couple of ways. You already figured out the radius was 20. And so 5 plus 20 will get you to 25. Or you could take 45 and minus 20. If you didn't know the 20, well, then you could just say, well, I know it's going to be halfway between 45 and 5. In other words, it's going to be the average between the maximum and the minimum. The center is always an average. So if you took 45, which is your maximum, and added 5, which is your minimum, and divided by 2, that would give you the average and give you 25 as well. Now we have a formula that our period is 2 pi over our b value, and by now you might have seen that a couple of times we've rearranged that formula, so these are both useful formulas. If our period is 2 pi over our b value is 2 pi over our period. So when you have the graph, you can easily see the period, and that means that our b value is 2 pi over 2, which simplifies to just be pi. Now I'm going to put my dots there because we always do dab C and sort of did a graph first and then figured out the C value. Same thing here. If we want to make a graph for this, we can, if we want to make an equation for this, we can make an equation for sine and cos and put everything in except for the C value. And then look at our graph and figure out what the C value is. Because the D, the A, and the B value are going to be the same whether you use a sine graph, a cos graph, a negative sine graph, or a negative cos graph. The amplitude for both of these is 20. And I'm going to just leave a tiny space in front in case we want to add a negative to make it a negative sine graph or a negative cos graph. We're going to make one equation sine and one equation cos. Our b value is pi. Well, I'm going to not write the minus sign yet. I'm going to leave space in there for my c value. And then my d value is 25, so that would get added at the end. So the d, the a, and the b value are not going to change whether you use a sine graph or a cos graph. And from this graph, we could make 10, 20, 30, infinite different equations. There's tons of right answers, all depending on your c-value. So let's start with our sine graph. If we want to think about a positive sine graph starts where? Center line going up. When does that happen? Right here, right? 0.5 to the right. So how do we write 0.5 to the right? Minus 0.5. There's our sine graph. Where does a cos graph start? At a maximum. When is our first maximum? 1 to the right. So we could write, here I'll do it in black, minus 1, and that would be a cos graph. The most common equation for this graph is this one. Why do you think this is the most common equation? The graph is starting at your minimum. So if you start at your minimum, you don't have to worry about any shift. Notice there's no shift inside. The c-value would be 0. You could, if you wanted to, put brackets and go x plus 0, but you don't need it. And so that is probably the simplest one, but then it's a negative cos graph. Right? And you could have chosen a negative sine graph and shifted 1.5 to the right. Or you could have done another negative cos graph and had a shift of 2 to the right. So there's a lot of different options. And when you're asked to create an equation, in some questions you'll be asked to create equation in sine and one in cos, then this is going to happen. Now, this next question, the reason I wanted to get you to graph it, is very similar to the Ferris wheel. Notice the Ferris wheel had numbers on the bottom that didn't have pi, right? It took 2 minutes to do the whole period. And that's probably more realistic of real life examples. They're not going to say, oh, it took 365 pi over 85 days for the sunrise to repeat itself. They're not going to use pi. They're just going to say it takes 365 days, because that's a whole year. So in most real life examples, we have actual nice numbers for our period, or at least decimals. So we're going to go and we're going to graph this one. Again, we're going to use our technique, starting with our center line. Dab C, what is our center line here? Plus 2, so draw that in at y equals 2. Our amplitude is 3, so we will go up 3 to our maximum of 5 and down 3 to our minimum of negative 1. Our period is 2 pi over our b value. And this time our b value has pi in it, and those pi's will cancel out, and you just get 2. So you mark 2 somewhere along your x-axis. Split it into 4 equal sections. 0.5, 1, 1.5, and 2. And then we can temporarily graph, because we've done the d, the a, and the b values. We can temporarily graph it, and then we can do our shift afterwards. It's a sine graph. Where does sine start? Center line going up, back to the center line, down to your minimum, back to your center line. And this is our temporary graph before we've done any horizontal shifts. Then we look, how do we want to shift this? It's going to get shifted 1 to the right. So the one at 0 gets shifted to 1. This one gets shifted to 1.5. And there we have our final graph. So the green one is the graph without the horizontal translation. And then we take all 5 of those points and just translate them 1 to the right, and we get our final graph. And so our final graph here has no, along our x-axis, doesn't have pi. And that'll happen quite a bit when you're looking at real life examples, because you'll be dealing with time and actual numbers.